Thank you so much. Good afternoon, everybody. Thank you for staying here for this talk. It will be hopefully very exciting. It's certainly a topic that is very dear to my heart. I've been working in malware security for Google for a couple of years now, and I want to introduce some aspects of malware analysis, vulnerabilities, and unwanted software that are relevant to developers, to software developers. So the talk is structured in the following way. I'm going to introduce the platform, the Google platform in general, and then we're going to go into some specific recommendations, tips of what not to do as a software developer of malware applications. The goal today is to introduce the Google Play Protect platform, because in the end, the applications that you will develop and that you will publish on the Play Store are going to be scanned and analyzed by our technology. And number two, I want to communicate some of the most common pitfalls that we find that may end up with your application being flagged as malware, and as a result, a warning may be issued to your users. So if you want to avoid that, then you're in the right place at the right time. Two sections: the pipeline that I mentioned. Number two, some common pitfalls organized in 4 parts: disclosure to users, monetization, dead code, and vulnerabilities. I'm going to mention 3 main categories of vulnerabilities that you want to keep in mind when you build your application in order to prevent security issues with it. And finally, some concluding remarks. Okay, so section number 1, the Google Play Protect pipeline. Who's heard about Google Play Protect before? Is the de facto application? Some of you were in the talk earlier today. Is the pre-install malware scanner, if you will, developed by Google, that is part of all certified Android phones. As part of the certification process, there's some tests that need to be run, and some modules, including mobile services, can be installed on the device. It allows you to access Gmail and Google Maps, etc., and other services, including Google Play Protect. This is a screenshot of what you may see on the interface of Google Play Protect. The application is going to be scanning all applications installed on your device, and it's going to be checking when you install an application, either from the Play Store or from a different source, to make sure that you're installing an application that is safe. If it is not safe, as defined by the systems that run behind our platform and our reverse engineers, we may give you a warning and we may give you a recommendation. We don't think you should install this application. Or if it is really damaging and we are very certain that this is malicious, we will help you prevent the install from happening. This is the most widely deployed platform for security in terms of mobile device protection in the world, and that's because of the customer base the user base for Android. It gives you the ability to install the application even if you want to, when the potential damage is not very high. But it will block the application if the application certainly comes from the Play Store, or when we know that the application is malicious in the categories that I will introduce in a minute. And finally, it scans the application and scrutinizes the application regardless of the origin. If it's an application that you develop on your machine and you sideload it over the debugger on your machine, that's going to be scanned by our Google Play platform. We have an option to share samples with us, with our backend, for applications that we have never seen before, so that we can feed our analysis platform, check for security and privacy issues, and then protect yourself and as well as other users. What are the types of bad apps that are in the scope for this protection? There are 2 categories of applications: potentially harmful applications, what we call PHA, and mobile unwanted software. You may have heard PUA, unwanted software, depending on different companies how they handle the nomenclature. But these are the 2 categories that we have in the scope. This is information that you can check online. We have very good definitions and examples online. Number 1, potentially harmful applications. This is the category with the higher risk to the user. These are ransomware, spyware, backdoors, phishing, etc. They may put the user or the device at risk, and for that reason, we flag them as potential high risk. These are applications that are scrutinized by our platform and analyzed by our reverse engineers to make sure that we flag them for whatever suspicious behavior we are able to identify. It may be the case that these PHAs may only damage a few users. Why? Because the device may not be prone to that attack, right, or that type of functionality. Maybe the abuse is based on a certain version of the operating system, a patch level of the operating system, so not everybody may be vulnerable. and maybe affected by potentially harmful applications. And in some cases, these potentially harmful applications may be applications that users want. Who's heard about King Root? Raise of hands, show of hands. Yeah, so you may want to root your device. So that is it is not malware in the sense that it's not being deployed to root your device en masse. But you as a user, as a power user or developer, you want to root your device. You want to experiment, or you just want to have that privilege. So that is not PHA. That is a potential harmful application. Why? Because it may leave your device in an unsecured state. Right? If you do not re-enable some security protections that are offered by the platform, then your device may be in a vulnerable state after you run that application. Same thing with Lucky Patcher. Who's heard about Lucky Patcher before? Lucky Patcher is an application that allows you to patch other applications. Is that malware or not malware? Well, we want to believe that it's a tool that users can use. So we cannot say this is malware, was created for with harm in mind. But if you execute and you patch an application, you may be, there may be some properties of the application in terms of content protection, licensing that may be disabled. Let me type in my password again here. All right, so that is the potential harmful application category and is the higher risk. In a lower severity risk, we have mobile unwanted software. These are not considered malware per se, but they may represent a bad experience to the user, and in general, the users may not want those applications on their device. I will introduce some examples in a minute, but they are tracked separately because we have these two categories, high risk and lower risk. These are the PHA categories in the scope. From the names that you see here, you see some obvious risks in the case of phishing, right? Credentials being exposed. We don't want that to happen. It may increase the risk to the user if this is credentials to their bank account, credentials to the social network account. We want to identify and characterize those behaviors. We want to develop models, rules, signatures to detect these behaviors and shut them down as soon as possible. I want to highlight a couple of them. One of them is backdoors. Why is a backdoor a security risk? Because it opens the device to control by an outsider, by a third party that the user may not know. And number two, hosted downloaders. Why a hosted downloader is a problem? These are applications that may download other malware, other PHAs or mobile unwanted software onto your device without your knowledge. In the end, you end up with, you wanted to download one application and you end up with 10 applications. Why? Because the application itself is abusing the install privileges of applications. So you see, this is the range of high-risk behaviors that we have on Android. And for the lower severity risk behaviors at the application layer, we have 4 categories. Number one, disruptive ads. What is the security or privacy risk of a malicious, of an ad just in general, or a bunch of ads on the user? Well, that's probably not very clear, right? The data is not being compromised, credentials are not being compromised, the device is in a secure state. But it may be a very bad experience, especially out of context advertising. You go to your lock screen, and then all of a sudden you have ads on your lock screen. That may not be an expected user experience. For that reason, the user may not want that. Similarly with click fraud. In the case of click fraud, there's a manipulation of identifiers that may allow a company to divert revenue, right? Divert money in such a way that they get credit for an ad that they didn't display, that they were not part of that workflow. But there's some manipulation that allows that money to be going to a different account. What is the security and privacy risk to the user? Not very clear, but it's really a bad experience. It's a bad experience for the developers, for the community, it's certainly the advertising platform and companies that rely on advertising through your mobile applications. The other one is impersonation. You may find a game, you download the game, and it's not really the game that the authentic game, but it looks like the authentic game. Is there a security or privacy risk? Not directly, but the company itself, the developer may be affected, the business gets affected. For that reason, it's something that we want to protect against. And finally, data collection. Data collection is differentiated from spyware in that the data collection categories are data pieces that are individually not very sensitive. For instance, exfiltrating your phone number. If an application is taking your phone number and sending it off device, we consider that lower risk compared to your SMS messages, your email, your pictures, and your browsing history being sent off device, right? These are two categories of severity. In the case of data collection, we cover a small range of data pieces. But again, it's something, these are applications that the user may not want, right? Maybe the application offers some value, but in the back end, in the back is sending information off device, maybe impersonating an app. How do we respond to those two type of applications? We have two options. We can respond in an informational manner, and we can tell the user, this application, based on our systems, is trying to hijack your credentials. We don't recommend you from proceeding with the game or whatever it is. But the application itself may offer some value. So the user may say, yes, I still want to do it. I want to download it. Great. The interface, Google Play Protect, will allow you to do that. In the case where the harm is very clear, is very palpable, maybe financial, it may be that you're going to be charged money, your carrier is going to charge you money, your device is not going to be available for you because there's a piece of ransomware that is within the application, right? So in those cases, we definitely want to block it. The application is not allowed on the Play Store, and we will not allow the device to install it. In this case, you don't have the option to whether or not to install it or not. Now, the problem is that the application may be pre-installed with your device. And if you buy a device certain types from certain manufacturers, it may be the case that it already comes with applications that may be escalating privileges, sending your data off device, right? And if they are installed on the system partition, what is the problem? That you cannot uninstall them, right? You may be able to disable them. And that's one of the tools that Google Play Protect uses to protect users. We try to disable applications that cannot be uninstalled, but at least we suspend the execution until the user decides to, if they want to re-enable the application. Why do we call it potentially harmful and not malware? Why don't we just call malware, all these applications? And the main reason is because, as I mentioned, applications may be created with a positive intent. In the case of rooting application, let's say King Root may be downloading exploits in such a way that it finds a way to get root on your device. That is not necessarily bad. It's bad when the user is not alert. It's bad when the user is not being notified, hey, by the way, we are escalating privileges. In that case, it is a problem. But applications like King Root, Lucky Patcher, and other applications like Power Tools are very useful, are very, very useful to software developers in particular, and security researchers in particular as well. So we want to call them potentially harmful because in certain instances, they may be abused, and they may be executed with malicious intent. I'm going to introduce the application pipeline so that you're a little bit more familiar with how the applications that you upload onto the Play Store are processed for security and privacy scanning. Number one is the fetching of the application. Number two is the generation of signals that are exposed from the execution of the application and from the APK itself. The score engine is the third phase and allows you to utilize the data that was generated in the second phase and characterize a malicious family, malware family, a PHA family, a MUwS family. It allows you also to create machine learning models, signatures, in order to catch these applications on a continuous basis. That's what our team does. And finally, the human review part. When we cannot automate the detection or the detection is not sufficiently strong, then we want to rely on human expertise to determine whether or not we think that the application is malicious or not. So let me talk about each of them in particular. Step number one, this is the source of applications, APKs, to Google Play Protect. Number one is the Google Play Store. As a developer, you write your code, you upload it into the Play Store. As soon as you upload it and it's ready for even before publishing, we can scan the application and we can say, hey, there's this malicious behavior here. We may email you and say, are you aware of this click fraud behavior within your application? Maybe you use a third-party SDK, right? More than 80% of code in average in an APK comes from third-party libraries, from SDKs. So it is likely that you incorporated some SDKs, but you may not be familiar with 100% of the code. So through the scanning, we may be able to identify malicious behavior that is part of an application that was uploaded on the Play Store. Option number two, The device itself has the option to send applications to the backend, to Google Play Protect, and this is an option that is available through your settings, and you're consenting to sharing some of the samples, the APKs on your device, Google Play Protect, for purposes of scanning. And there's malicious behavior, then we may warn you, we may alert certainly other users, and that's how you collaborate with Google Play Protect, how you help improve the platform. Number 3, OEMs. The build test suite is a set of tests, security tests, that system images go through. So OEMs that are going through the process to certify their phones as Android phones need to go through this and many other tests, quality, display quality, the version of the operating system, et cetera, et cetera. In the case of security, there's the BTS test suite, and we are able to take the system image and extract all the APKs. Right? That's how we can feed also Google Play Protect. We have infrastructure that allows you to see all the applications that are pre-installed. And this is a very good source of malware, unfortunately. There's a lot of applications in some phones that are exhibiting malicious behaviors that unfortunately come with some pre-built images on the phone. And what else? We also have a very strong network of researchers, developers that collaborate with us and share their knowledge. They share their samples, they share their findings. Certainly antivirus companies, they may say, hey, we found this application on the Play Store. It's malicious. Why is it still there? Well, we take a look, we validate the findings, and we quickly try to remove it and alert users. Of course, that happens automatically. Also, there are maybe academic institutions, our partners and security researchers that are doing their own work. Let's say that you are at school and you are getting your degree in computer security. You may be finding a new family of spyware. And then you send us those samples, you share with us your paper and the samples that you identified. And of course, we will try to respond to that as soon as possible to remove the applications from the Play Store, retrain our systems to make sure that they detect other similar applications and automatically alert users. Again, not only about applications that come from the Play Store, but also they may come from third-party stores, or they may come from a system image that was preloaded on the device. What is the scale of what we are talking about in terms of malware, mobile unwanted software, and vulnerabilities that I will introduce later today? This is the scale, is 2+ billion devices that you've heard today, in terms of the scale of the ecosystem today. And in terms of the scanning that we do today in terms of malware through Google Play Protect, is more than 1 billion device scans per day. Why are we scanning over and over devices and applications? Because new knowledge is produced every day. Our research teams are identifying new threats every day. Academic researchers and our partners are discovering new ways of abuse and new malware families that are used to enrich our system, and at the same time, we try to automate the detection by implementing rules and machine learning models, as I'll introduce in a minute. What is the step number 2 after we get the application on our hands? We have this collection of APKs. Just visualize a database with a lot of APKs. Well, we want to decompose the APKs. If we want to execute the APKs to expose as much information as we can about the workflow, the network traffic, file access, assets that are being dropped with the APK, APKs that may be downloaded by the APK itself. And so we have these 2 categories of signals in the second phase of our pipeline. Dynamic signals that come from the execution of the application. It may be an emulation, or it may be other technologies that we use. In the end, we want to expose network traffic. What servers are we talking to? What IP addresses are you using? What parameters are being passed with those gets and posts that we see in real execution of the application? Number 2, what files are being used? What are we writing to files? Are we reading files? What is the cadence? Can we characterize that behavior? Number 3, permissions. What permissions in practice are being used by the application? One thing is to declare your permissions in your manifest and the application, and the other one is to use them. So in practice, what is being used? At what point these permissions are being used? And can we use that as a signature to detect a family of malware? And finally, native code usage. In real time, are we loading SO files? And if so, what are we using them for? Can we observe that at runtime? The other category of signals that we produce in the analysis phase is static signals, and these come from the APK. they come not only from code index files, they also come from the manifest or any asset files that you may have. You can think about hashing, for instance, all the images that come from the APK. You may think about all the permissions that come in the manifest. The manifest itself, it may be fingerprinted. I may know that you're the developer because your manifest is, I already know how you structure the manifest, right? And it may be a signature that may allow me to catch applications that you developed as a developer. In the case of malware developers, it may help us detect more applications that are malicious. Certainly strings is a very, very powerful tool, the ability to understand strings and expose strings from the APK. And execution workflow, what classes are being defined, what methods are used, and what is the connection between those methods and what are the parameters that are being used. So these are all data pieces that need to be exposed during the analysis phase. We want to expose as much information as possible we have the APK, then we have a bunch of signals. What is the next step? Now let's try to utilize intelligence to link all those pieces together to then characterize a malware family. The backend that supports Google Play Protect includes 30,000 CPUs dedicated to our analysis and our scanning. The scanning, as I mentioned, happens on a regular basis on devices, and on our database, we have 1.2 million applications. That is the size of our database. We need to scan them every day. Why? Because today I may have not detected the ransomware sample that is just being discovered. There may be a very recent discovery that was not known a few weeks ago. So we need to scan every single application every day, right? And that complexity increases. You need a lot of computing power. Google, fortunately, is able to provide that computing power. Number 3, after the fetching and analysis phase, we want to determine what is the risk level. So the outcome of this score engine level is a number that tells you, hey, this is an application that is 95% suspicious, and this is the reason, right? It's not only a number. The human also needs to understand. In some cases, if you're working with machine learning, for instance, you know that there's some models that are difficult to interpret. And on the other hand, maybe other more practical methods, logistic regression, for instance, that allows the human to easily interpret why the model is saying that this application is similar to these other applications. The score engine in general relies on multiple signals, and not only machine learning, but other statistical methods, if you will, to give you the confidence that an application is malicious or not. In this analysis phase, we produce the knowledge such that we can get this type of information. We know that a phishing URL has been detected. Why? Because maybe there's 50 different applications that we have categorized as spyware that are linking, are sending information or PII to this backend, right? So we have the ability now, connecting all those pieces from exposing the second phase. We compose a model, we compose a characterization of the malware family that allows you to detect them in real time during analysis. We may be able to say the application is trying to write to a read-only file. The application matches the description of a routing family, or the application is signed with the same key that this routing application is signed with. Right? We may have the ability to do that. And in the case of clustering and other models, you may be able to say this application is similar from the code point of view to these other applications. Or we can measure that also in terms of similarity, code execution, network traffic. It's more complex, but it can also be done. This is what the third phase of our pipeline allows us to do. And when the characterization is very solid and we have certainty that the malicious behavior is there, then we can link it to an automatic response. As I mentioned earlier today, we can warn the user or we can block the application. In terms of automation, the volume is so high, we have a moderately sized team. Of course, we can do more with more people every day, but we need to automate. We need to be efficient. And one way to do it is to utilize signatures, detection rules, and any other algorithms that allow us to understand what are the fundamentals in terms of behavior of an application and how we can detect other applications that are similar. Either to send them to a manual analysis, that is our last phase, or automated classification. The chart that you see here is a similarity chart that allows you to see, okay, in the case of backdoors, all these applications in this part of the universe are similar in terms of code. I think this chart is derived from code in terms of code similarity. How to measure code similarity? That's a different story. There are different techniques to do it. But you see the steps. So finally, if we cannot automate in the score engine phase, we cannot automate and determine with a high level of certainty that an application is malicious, then human expert will take a look at them. Of course, there's already a lot of information that was provided from the previous phases. We have the decomposition of the APK. We have the opinion. Let's say that there's 5 machine learning models that say, oh, we think that with 30% confidence this is ransomware. Okay, that's not a high confidence. Okay, maybe the human is going to take a look and then make their call, and hopefully help us improve the models. In the case of human analysis, it requires the reverse engineering in many cases of the application. It involves in many cases the obfuscation and unpacking of the application so that we can expose code that they can be matched by our rules and our methods. Without having code, in this case, for instance, Java or small strings, we may not be able to execute those methods. So we need to invest in that manual analysis. The benefit is that if you are able to reverse one of the obfuscators or packers, then you may be able to reapply that to other samples, other APKs, and in that way expose more signals for potentially harmful applications. This type of analysis manual is not only for Java code that comes from your DEX file, is also native code that was developed for that specific device and that may be used to hide code and behaviors. The application may be using SO files to install other applications and have access to some local resources. So it's not only Java code, it's also what the JNI, the native interface, allows to load in terms of code. And one of the challenges, as I mentioned, is the obfuscation and packing. In this case, you see a lot of variables and class names being named A, B, ABC. That doesn't tell me much. So the reverse engineer needs to do a search, understand the logic, and they start naming those parameters the way they see fit. Now, what are the common pitfalls that a development team may be running into, and that may result in the application being classified as a PHA or as a MUwS, right? So I'm going to mention some of them. Keep this in mind so that you don't have to go through, file a ticket with us and have to be in touch with us because your application was removed from the Play Store. In this screenshot that you see here, we're saying the application is blocked. This app can damage your device, add hidden charges to the mobile bill, or steal your personal information. That is the screen that you will get when a PHA is detected. And what are the common pitfalls? Let me list all of them, and we'll go into some of examples. Insufficient disclosure to the user. You are not very clear, we are not very clear about the data that is being used from the user, how much the application is going to cost the user in the end, etc. Insufficient disclosure is top one issue that will result in your application being removed from the Play Store and flagged as malware. These are two different things. The application may be removed from the Play Store, but the application may be still installed on the device. So the Google Play Protect may still give warnings to the user when the application is still installed. So we try to synchronize both of them, and in some cases, the removal from the Play Store, the status on the Play Store, and the flagging as malware by Google Play Protect may be different. The use of malicious third-party SDKs. When you include code for whatever reason, that may include malicious behavior that you were not aware of. Number 3, using monetization methods that may be controversial and may be damaging in some cases to the users. And I'll mention a very specific example. Incomplete fixes to your previous version of the application. Maybe we said, hey, you are not encrypting traffic. You are a backup application for SMS for your contacts, and when you send all the information from your your contact list on your device, you are sending it to your backend without encrypting the channel. That's a problem. If you didn't fix that and you uploaded a new version of Play Store, guess what? It's not going to be approved. Misleading content. These are applications that may offer the user certain value, but in the end, they are doing shady things behind the scenes. And misinterpreting our policies. You will see my last slide is my recommendation is to become familiar with the policies that we have on the Google Play Store for developers, so that you can understand what we consider PHA and MUwS and what is safe behavior. Now, let me go through some examples. They come from the test application that was developed. These are not the screenshot from the actual applications, but the behaviors, and what you will see, the examples are inspired on the actual behaviors that we've encountered during our day-to-day work as reverse engineers supporting Google Play Protect. Number one, the first category, disclosure. Collecting sensitive data. Let's see what this screenshot may be saying, what the application may be saying. We just uploaded all your sensitive data to our servers. That's past tense. Yeah, the data was already uploaded. Please click accept below to continue using this application. This may be obvious, that they may not fly very well. Why? Because we are not collecting consent and authorization from the user before proceeding. So we are acting earlier. Not only does this happen with data exfiltrating, but also with payments. The user may be charged before they even know anything about the application. They have been already charged. Of course, that behavior we don't want on the Play Store. You need to avoid at all costs to run into this type of problem. Number two, we may upload your data. Okay, what data? What data pieces? At what point? For what purpose? So this is vague about the scope of what is being disclosed to the user. It's not very helpful. 3, terms of service. Super detailed terms of service here. Please visit this website. If you look at our guidelines and policies for Google Play, the Play Store, you will see that the notification needs to be in-app. It needs to be very clear to the user right there. Right now, we're going to send your backup. We are backing up your information. So right now, we're going to be sending the information. So it needs to be meaningful. It needs to be in front of the user during the app in-app. It cannot be in a different website. Of course, you can have your website with the terms of service. That's very helpful. But also, the user needs to see them right there. Let's look at this example now. We may upload the following data to our servers to help create a better user experience. Contacts, SMS, embarrassing selfies, audio of your singing in the car, and continue, please. So who thinks this sounds good? Any serious? Huh? Why not? Yeah, maybe there may be other information that may be exposed. Well, this looks good from the point of view that we are doing it in app. We are listing the applications that are the type of data that is being used. We are alerting the user. However, in this case in particular, the problem is that the information, the PII from the user that was being collected and sent off was not protected over an encrypted channel. So that was the problem. In terms of the disclosure, it sounds pretty reasonable. Let's go to billing and payments issues and potential pitfalls. This app costs money. Who thinks this is a good idea? Show of hands. Nobody. Only me. Okay. Well, the problem is we are not being specific about the currency and the cost. That is very. The user must know what the cost is to them. We just added a charge for $1.99 to your mobile bill. Now you have access to all the latest features. What is the problem here? We may have not asked the user in advance, we are ready to charge you, accept the charges or not. Now, in some context, when the user is downloading the application, they may be already been signing up for some terms of service. But in the case of using PII and charging the user money, this is so sensitive that we want the user to be alerted right there, and of course, for the user to have the opportunity to give authorization. Get us some features. Please accept a charge to use this application. The amount you are charged will depend on your country or carrier. You don't know how much it's going to cost you. Maybe it's going to be $1,000. It may be 1 cent. Right? When you are not specific, our Google Play Protect policies will catch this application and will prevent you from publishing it, or will remove it from the Play Store. Vague and or misleading. Get these awesome features. This app is a paid service. Click OK to send a premium SMS message for a recurring payment of $0.99 a month. So we are clear about the amount of money. We are being upfront that this is going to be a paid service, We are upfront in the sense that the user is going to be committing to a recurrent payment. So that looks pretty good, detailed and prominent. But when our reverse engineer tests to make sure that the number to stop is in fact operational, it is not, right? So that's another reason that your application may end up being classified as not benign. Great, let's talk about a second part. This is monetization. How you as a developer may be making money. In some cases, it may be a method that you use for selling in-app assets. In other cases, it may be that you incorporate an SDK. And the SDK, it may be an advertising SDK, and you may monetize that way. You may be also doing analytics, and you may incorporate into your APK an SDK that is doing analytics for you and offering you a lot of information. What is the challenge here? The challenge is that maybe there's additional code that is doing many more things on top of that. And that is a very common risk. Again, 80+% of code in an APK comes from SDKs. And if we don't understand what is being incorporated into our APK, we are responsible for that APK. If I'm the developer, I'm responsible for that APK. I'm the one whose revenue is going to be affected if the application is removed from the Play Store. So best practices rely on SDKs that you can trust, partners that you can trust. When you incorporate ad SDKs and analytics SDKs in particular, be aware of how the monetization flow can be abused. Because in the end, let's say that you are part of an ad, you are joining an ad advertising network, your application is displaying ads, that's great, you are making money. However, the application may be vulnerable to click fraud. There may be a very easy way to manipulate the credits for those ads in such a way that you may not be making the money that you are expected to make. So try to understand what is the sophistication and the safety of the code that you're incorporating, specifically with ads and analytics SDKs, which is our experience. There may be different risks that you may be running if you don't scrutinize and understand what is the code that you're incorporating into your APK that is distributed to the user. Crypto mining, that may be a way to monetize. You may say, hey, the user is going to be able to, we're going to be using portions of your CPU to mine cryptocurrency. In the end, the user may not benefit in practice. For that reason, we don't allow crypto mining applications on the Play Store. We allow crypto mining wallets, but not applications that are mining and they're using the SoC power to do crypto mining. And specifically in terms of proxies, there may be applications that may be routing traffic on the behalf of a paid user. The device, you install the application, and the SDK that you incorporated may allow a paid user in a certain platform to route traffic in a VPN, in a proxy way, in such a way that those paid customers may be able to access resources that you can reach with your device, but the user is not going to know what type of traffic and what type of assets are being transferred through the phone. So those are proxy networks. You can read about residential proxy networks and some of their security challenges. I have 2 minutes, and with that, let me talk about dead code. Dead code, we consider code is code that may not be executed depending on the configuration, or that it cannot be because of configuration, or because the logic itself it will not allow the code to execute. What is the problem? That is, the code itself is attempting to do something malicious. For instance, disable SC Linux, disable security protection, disable Google Play Protect without the user's knowledge. Even the fact that the code is present on your device is going to alert our systems, and they're going to say, hey, this is an application that is trying to root the device, disable SC Linux, etc. It's very difficult to prove execution of code, as you know from Computer Science 101. For that reason, if we detect code that may be damaging to some devices, we don't try to see if 1% of the user base is going to be able to execute this application. We just take the conservative approach to say, well, this is malicious. We may give the user a warning. We think that this is malicious. Please do not execute it. With 20 seconds left, let me talk about my concluding remarks, and I'm going to list some resources here. Number one, disclosure to users is very important. You need to be accurate. You need to be upfront. And having those two things in mind will save you a lot of time in terms of your application not being flagged as potentially malicious. When you incorporate SDKs, try to understand what the SDK is doing. If it is open source, you may have the ability to scan it and scrutinize it. If there's something that is being offered to you in terms of monetary compensation, try to understand does it make sense? How are they monetizing? How are they making money and they are offering me a cut of that? If you try to understand that, you may be able to dig deeper into what the developer is trying to do and determine whether or not this is right for your users in your application. And finally, become familiar with the policies, what PHA is, what MUwS is, what we allow in the Play Store, what are the risks that we consider important versus what is safe behavior that you may be considering implementing in your application that may be controversial, but there may be already a policy there written for you to understand more. These are 3 resources that I will recommend. Number 1 is our developers' website is very, very, very good. It has a lot of up-to-date information, in particular for the Play Protect section. The Play Protect section will list some resources not only for best practices for developing applications, but also how the scanners and our platform is detecting or not these behaviors. Number 2, the privacy, security, and deception. There's a typo there. Website that lists some of the findings that are most notable that our team has dealt with. It will allow you to understand how developers got into trouble by relying, for instance, on SDKs that they didn't understand much of at the beginning. And finally, our best practices for security. The section that I didn't have the time to cover, it was 3 examples of vulnerabilities, protecting traffic, PII, when it is being sent off device, and protecting your file paths, etc. You can get all that information on the developer website also by looking at best practices, or you can just rely on Google and find information about how PHA is being classified, what malware categories are the most prevalent, and how you can avoid being hit by malicious behavior on your applications when you develop them. Thank you for your attention. Thank you for your time. Enjoy the rest of your day here. Thank you.